Alright, so let's just go through this then for the sake of the others who are not here. Alright, so we have these questions. I sent them in the group, and these are exam CSEC questions. I will just file these randomly. So these are from past papers. So questions like these you will be seeing. Right, so the first question says express the function f of x in this form. So again, you need to understand, remember what form we call this form?
The vertex form?
This one is vertex form.
No.
This is the quadratic form. Good. This is quadratic form, standard quadratic is standard vertex. Good. And this form is preferred for sketching the graph. Right? Each piece of it has a significant important in terms of how you sketch a graph. Then they ask us to find the value of x, at which the graph cuts the x-axis. So we just talk a little more about that.
Good afternoon, sir.
After the interval for which f of x is less than 0, less than or equal to 0.
Sorry.
And then we want the minimum value of f of x. And then we want to find the value at x where we actually find the minimum. So they are slightly different, but you need to understand. So once communication part of the question, once you understand clearly what the question is asking, then the doing part shouldn't be so rough, right? So first thing you want to do is go from quadratic form to vertex form. Remember what we call that process? It's called completing the square. Alright, so completing the square takes us from quadratic
to vertex.
Takes us from the quadratic form. Quadratic to
Vertex.
vertex. Quadratic standard quadratic ax squared plus bx plus c. And this is a bracket x plus h all squared plus k. So I'll go in this way. Coming back the other way because I just expanded. So if you get this form, you just expand the bracket and simplify it. And you get back into the standard quadratic form. Alright, so let's try and do that. So that, if you remember, wasn't too difficult. Right? So we'll start out with 2x squared minus 4x. And we'll put that little space here, so minus 13. Right? So we'll add something here and there. But before we can add it here and there, we need to make sure that the coefficient of the x squared is 1. So we divide out that. So we're going to factor out our 2 there. Alright, and then it's going to give me x squared minus 2x. Still leave the space. Minus 13. Alright? So if I were to distribute this 2 times, everything here is back up here. That's perfect. So I haven't done anything significant yet. So what goes here now is a half. So I'm going to add here a half of this number. Half of 2 is 1. Again, half that by the square. But remember, everything inside here gets multiplied by 2. So I'm going to have to, if I added something that was not there, I'm going to have to subtract it out. But it's going to be 2 times everything that I just squared. Alright? The 2 is important because there's a 2 subtracted. If there's nothing there, I'll just subtract it 1 squared because that's all I would have added. Cool? So everything inside this bracket is multiplied by the 2. So if there's nothing there, there will be nothing right here. If there's a negative 2 here, there will be a negative 2 right there. Right? Well, everything that I factor out has to go there. Next part is just complete the square. That part should be easy. Just take down the values of the squares. X minus 1 squared. This 2 comes right down. Alright? But inside the bracket, rather than write back all these 3 terms, we just pull out the 2 terms with the square. Whatever comes after x squared, that comes out down. See that? Now all we have to do is just work out this last bit now. So we have 1 squared is 1 times 2, that's just still 2. So we have negative 13 minus 2, that's just negative. So you now went from quadratic form to the vertex form. Alright, so we completed the square. Go to that?
Yes, sir.
That's part 1 done. So part 2 says, find the value at which the graph cuts the x-axis. So the x-axis, again, to give you an idea of what's happening there, when you cut the x-axis, which one is the x-axis? The horizontal one. So this is my x-axis. So any line that cuts the x-axis, what's the points? What's the coordinate of these points here? So let's say I put 1 here. What will the coordinate of this point here?
2.
So 2, comma 0. And if I pick another point over here, so let's say -1, -2, this will be what?
-3.
-3, comma 0. And any point I pick on this line, the x value is some number, but the y value is always 0. So what am I saying? If you want to know where the function cuts the x-axis, it is where y is equal to
0.
it's the point is the point or points where y is equal to 0. Right? So we don't know if it's 1 point or if it's multiple points. So all we have to do is what? Set the function to 0. So either the function in vertex form or in quadratic form. Yes.
Sir, I still don't get it.
Don't get it. Which part?
I have to use y-axis and x-axis.
Question told us to do. The value of x at which the graph cuts the x-axis. So we're saying that once we cut the x-axis, any point on this x-axis may have an x value, a number for x, but for y, how going to be what? 0. The y being 0 is fixed. We don't know what the x value may be, but we know the y value will be 0. So whenever a question asks us to find where the graph cuts the x-axis, it is essentially asking us to solve for when the y is 0. Get it? Essentially asking for that. So all I have to do is replace f of x, which is y, to 0. So whether this way or this one, whichever one you want to solve, you can solve either of the two. Right? So which one do you want to solve? You want to solve it from the quadratic form, or you want to solve it from the vertex form?
Vertex.
From the vertex. Okay, so part 2. So we're going to take all of this, which is just another way of saying f of x. So since f of x is equal to 2 bracket x minus 1 squared minus 15, that's in vertex form. Just make a note. This is in vertex form. We're going to just set all this to 0. Because f of x is another name for y. Right? So it's going to put 2 bracket x minus 1 squared minus 15 set this equal to 0. So how we solve this for x now? We bring everybody over where I try to get to the x. So first things first, we're going to bring the 15. So you have 2 bracket x minus 1 squared equal to 0 plus 15. 15. Right? Next, get the 2, we divide both sides now by 2. So the next thing I have is x minus 1 squared is going to be equal to 15 divided by 2. Next thing we need to get rid of is the square. So we'll take the square root of both sides. So we're going to have x minus 1. So now we're going to do the square root of 15 divided by 2. I will be staying with me here. It's undoing every process on a time. And then finally, if I want to solve for x now, it's going to be the square root, but square roots are both positive and negative. If you have 2, and then this minus 1 comes over down here. Plus 1. So these happen to be the two x values when we're at 0. You can plug this in your calculator to get the exact numerical value. So this is the calculator. What's the square root of 7.5? 50 divided by 2 is 7.5, right? Square root of it, 2.734. So we are on this out to x is plus or minus. Don't mash it up. Let's say 2.74. Right? 2.74 because hopefully for plus plus 1. So in one, so we could say it could be 3.74 or 1.74. Right? That's
Anyone?
No, it's both. Negative actually. It's positive 2.74 plus 1 will give you 3.74. Or negative 2.74 plus 1 will give you negative 1.74.
So you have to have the two of them, sir?
Yeah, because whenever you take the square root of a number, you need to be aware now that you get two values. Square root of 4 is not just 2, it is both 2 and negative 2. Right? So, whenever you solve it in quadratic, you usually may get, how they are to get two solutions. So those are two solutions supposed to be getting.
So now we undo this. I know we just say.
Yeah, we'll undo everything. Minus becomes plus, multiply becomes a divide, square becomes a square root, minus plus. Let's say like transpose an equation. So again, what was the key part there? The doing is okay, but the part you need to pay attention to is that when you're solving for it across the x-axis.
This one it gave me.
When you're solving for it across the x-axis, it is when y is equal to 0. So your thing gives you an answer as a fraction. No, not square root of 2.74 whatsoever. So square root of 50 over 2.
Oh, okay.
Hmm?
Yours is giving it as something, you have to know how to change it to a fraction.
Okay.
Alright, so we're at number 3. So part 3 now says what? Where is f of x less than 0? Right? Where is it less than
This one?
0?
Sure.
Yeah. Root 30 over 2, them square it, you know. And double that and double that. Right? So the third question says the interval for which f of x is less than 0. Less or equal to 0. Now, look what I'm going to do. And the question is presented in a way where each part builds on top of that. So we're going to take these two solutions because these were where it was equal to 0, right? Now we want to check where it is actually equal to or less than 0. So look what I'm going to use. I'm going to use as a number line. I'm going to use a number line to extract the solution for this. So follow me. Using a number line, what I'm going to have. So look at this. So on the number line, I'm going to put in my two zeros. Right? I have a 0 at 2.74 and a 0 at this, right? So this is going to be the negative 1, so called negative 1.74 approximately. And it's going to be
Negative
3.74. So at these 2 points, my function is equal to
0.
0. Now, when I'm talking about in less than 0 is what? Negative numbers. So I want to see for what x value, remember down here represents x values, right? So all these are x values where my function is going to be either positive or negative. So how am I going to find? I'm going to use some test values. So I need some test values. And your number less than negative 1.74. Your number less than negative 1.74.
Negative
A
1.74.
number less than it. Less than, no, like negative 2. A number between this and this, I could use 0. A number larger than 3, I could use 4, right? So what I'm checking here now is whether it's positive or negative. I don't need to know the actual numerical value. I just want to know if it's positive or negative. Because for you to go from maybe 0, you must be, well, most likely you're going from positive to negative. You could be positive towards your turn back up. That's all possible. But generally, it's negative, positive. So see the line here, you can pass this up. So it was negative down here. This is 0, that's positive. Or it could have been the other way. Positive, 0, then But I'm saying a few instances you could have it where the graph curve hit the 0 and turn back up. Positive 0 then positive. But we can investigate all that right here. So what we're doing is we're going to put these values into the function and see what we get. Right? So when you want to put it into this or this, you're just going to evaluate it. That's what we do. Right? So negative 2, we're going to put it everywhere we say x. So what if we put negative 2 inside here? See that we're using this. Negative 2 minus 1 is a negative 3. Negative 3 squared, positive 9. 2 9s, 18. 18 minus 15 is positive. So this will be positive number. Look how we got 3. Right?
Mm-hmm.
When you put 0 in there, what we get? 0. Right? Minus 1 is 0. Negative 1. Negative 1 squared is positive 1. 2 1s, 2. 2 minus 15 is negative, which is a negative number. See? Now here, if we put 4, positive 3. 3 squared 9, 2 9 is 18. 18 minus that, get back 3 again. So these values are
Positive.
So the question says, what is the interval where we are less than or equal to 0? Where is that?
Negative third.
From here so up to,
There, so.
so the interval is x is what? Less than or equal to 3.74, at the same time greater than or equal to negative 1.74.
7.4.
So that's the interval. If it was out here now, we would have had less than negative that, greater than that, I would have just put a union between the two.